All right. So today we are going to be sort of redoing the chatbot. Not exactly. We are going to essentially be rewriting it in a way that makes a bit more sense. We're going to be implementing sort of data structures to capture all the tokens instead of we're going to be representing the tokens as one data structure, and we're not just going to be making it functional. That's the approach we did last time. We did functional tokenization, whereas now we're going to be doing sort of stateful tokenization is what I'm getting at. By the way, if you're new here, please hit the follow if you're on Twitch, subscribe if you're on YouTube, leave a like, comment, do all that sort of stuff. I'm just getting my layout working. Let's go to our desktop. So here's what we had last time. Right? And I don't normally stream over the weekend. I know I kind of have been the past couple of weekends, but I try and keep my weekends open. Oh, by the way, I updated my schedule on Twitch. If you want to check that out, just head on over there. Yeah, so we're going to be essentially deleting this. We're going to be Control A, delete. Right? And then I'm gonna write a new hello world. stdio.h int main void return 0 printf hello world. We're gonna be just doing a new hello world just to confirm that our build system still works. Bin compile bin run, and that should work. Oh, it shouldn't work because I was fooling around with this. Compile Elixir. Right, and then yeah, so I want to kill finalize here. Yeah. There we go. That's good. Oh, and then I have to do bin build. Finalize. Cannot run command. Oh, okay, so that will be compile. Where else is finalize? Oh. And that should work. Yeah, authentication failed because it shouldn't run. We're going to kill main.exe, and we're just going to run the Elixir for right now. Okay, and then we're going to run Elixir. Okay, well, let's just forget about that. Let's do W extra. We're just gonna compile manually, because I don't really want to spend too much time on that. Pedantic, and we're gonna say Elixir .exe. Oh, no. Bin Elixir .exe Elixir.c. Great, cool. And then bin Elixir. That correct works. Okay. And we're gonna turn on optimizations because if it works with optimizations turned on, it will work with optimizations turned off. Good. All right. So we have our little thing working, right? So what I did over the over the sort of weekend, I guess I'll say, is I made some notes. I took some notes. Right? I just kind of I started thinking how would I create a stateful lexer? Right? How would I create a lexer with sort of separated responsibilities? How would I make this clean so that when I come back at it, I'm not like, what does this function do? What does that do? And I took some notes, right? I've essentially rewrote this lexer, right? I've essentially rewrote this lexer to a state where it works. And then I documented it. I documented what I did. That is what I've been doing over the past 2 days, right? I didn't stream, or no, it's been a while. How long ago haven't I streamed? I don't really care to look at it, but yeah, it was a while ago since my last stream. It was about I'm gonna say max half a week. But on YouTube, I kept uploading the VODs because I had a little backlog, so YouTube didn't really miss a thing. And that's why I'm streaming on a Sunday, is so that I can I can regain my backlog, so I can take a day off if I want to. Right. Okay. So let's get to it, shall we? So type def enum. I probably shouldn't have deleted the token kind enum, because that pretty much is gonna stay the same. Right. We got token. Let's see, what do we got? Token colon and token end are going to be the most important for right now. And right now, I'm kind of just trying to tokenize the... Oh, alright, so let's... Before we do that, let's do... Oh, is this zoomed in for everyone okay? Like, I've been messing around with the zoom for VS Code, and it's okay for me, but then I realized, wait a minute, there are some people that might want me to zoom in a little further, so we're gonna zoom in a little further. And I'm gonna check that actually. Hold on. So I have my stream pulled up on my phone, or you know what? Actually, I could just check OBS. Let's see here. Oh, all right. I don't want to move the OBS window, but that's good. I think that's good. That's okay for right now. I think we'll mess around with it over the next couple of streams. But what I'm going to do is I'm going to include double... Come on. Build kata lib c collections string builder, as well as define, right? Yeah, string builder implementation. I probably shouldn't have deleted that, but sure. Okay, so let's compile, and these are indexed errors. That's fine. Because I don't do anything, right? So is it entry? Do I also want? Probably, actually, yeah. Now that I think about it, entry implementation, because we are going to read from a file. Just like last time, we're going to read the same file. So we're going to do path. Yeah, path, sure. Is equal to path from which just takes in a literal test.txt. And I am going to print f, or no, actually path t, just to check where we are. We get the absolute path of path, because it's a view, we're going to pass it by reference. And then also because these are allocated on the stack, essentially, we don't have to deallocate these anymore, which is great. Yes. And we're going to print. Yeah, there's. Yep. Okay, so that's the correct one that I'm looking for. And then we go entry is entry init path. And what am I going to do with entry? Entry is we're going to do we're going to read entry, right? Yeah, entry read entry. If not entry read, because I'm pretty sure this is a boolean f print f. We can go to standard error. This is going to be an IO error. Cannot read from file %s new line. File. Oh, path as a string. Path. And we're going to return, return 1. We don't need to deallocate any of this. Well, yeah, no, we do, right? Yeah, we have to deallocate. So that'll be string builder delete, because we don't have entry delete, which is the address of, or no, entry content. So that's already a pointer, so we don't need to. And cannot find test.txt. Huh. Why can it not find txt? No, that's test. And we made sure up here, hold on a second, what? We made sure that this was the correct file, test.txt. Copy relative path then? Yeah, it's just test.txt. Okay. I don't know what that was about, but sure. Else we're going to print %s new line string builder data, and that would be the entry. Yeah, entry content. And then string builder delete entry content. There we go. All right, we read from the file. Awesome. So that's good. Right. Okay. So let's see. Token type def struct. No, I do not mean to do lexer. That's VS Code autocomplete token t. And that is going to have a token kind type. Now I really want to use, I guess I could use kind, just so we don't like flip the namespaces, because I think like switching between kind and type is different. I really want to use token type, but unfortunately we include libraries like entry that use Windows, and token type is already defined in Windows, in Windows.h. So I can't really use token type. So we're gonna use type. Yeah. And then how do I want to represent the data? Okay, yeah. I think I'm gonna use a string view again. Yeah. Because in my research I found that we use oh no, actually by defining entry we can use string view. That most of what we use are string views, sized strings, essentially. So you don't really need to have a separate structure for token data and token size. You already have that in a string view, in a size string library, which is all on the public GitHub, by the way. You know, if you're on YouTube, GitHub is in the links on my channel, as well as on Twitch. It's yeah, on the links on my channel. So if you want to go find any of the libraries that I'm using, head over there. Plus, I'll put it in the video description. Yeah. If you're on YouTube, put it in the description of the VOD. Yeah. So then we're gonna do string t, which is the size string structure, and we're gonna do view. I'm gonna call that a view because that's what it is. Right. Okay. So then we have our string view structure. So I guess a good way to do it would be to token init. Yeah. Let's do token init. So then we get a kind. Yeah. So it'd be a token kind, and then data, which is going to be a const string to data and size t length, and we're going to return a token type, and whoops. I probably could zero out a token. In fact, that's probably what you can do. Right, okay, because if we zero out a token, the token kind is going to be token end. That is the end of the structure. But if we zero out a view... Huh. No, well... No, I'm going to make this a proper constructor. So dot kind is going to be kind, and dot view, oh yeah, it's commas, dot view is going to be string, new, string view. It's going to be data and length. There we go. All right, that should be fine. Good. And then compile. Make sure all my syntax is correctly. English is hard sometimes. Yeah. Okay. All right. So that works. Awesome. Then we're gonna use. We're gonna get our lexer out of here. Let's get our lexer. Struct lexer t. And in my research, I think it was easier to sort of define a structure that contains linearly, whether we do eventually make this a stack or whether we do make this just, if we do keep this a linear list, a list, a structure to define a list of tokens, which I think the lexer's job, and this is really why we're defining two separate structures, the lexer's job is to just take in a stream of tokens, or a stream of characters, right, from the raw data that we get, and then just take that whole thing and make it a token. You know, make them tokens. You know, yeah. That not much more I can say about that. Okay, so then let's do token array type. It's self-explanatory. It's exactly what it is. Token array type is gonna be. I think I should make this a dynamic array, or no? I'm just gonna make this a sized array for right now. Yeah. Okay. So define. Just for now, and then, you know, once we sort of make sure everything's working, we can make that more robust and flesh it out a little bit more. Max tokens, and that let's just do 256. All right. So we're gonna say token type, which is going to be tokens, and that's going to be max tokens. There we go. As well as I think that's fine. I think that's okay. Yeah. All right, so let's look at our notes here. So these are... Oh, we didn't finish with the lexer. Okay, we didn't finish with the lexer. The lexer gets source, which is going to be, I believe... Is it going to be string view? We have a... I think it's going to be a const char, yeah, of source, right? And then const... Oh, no, wait, it's going to be size t cursor. Yeah, there we go. Because we don't need the length for the raw data, so yeah, that's fine. Okay, where was I? So we are going to need to initialize the lexer, and that's going to be lexer init, and the lexer init is going to take in a source, and that is going to return lexer t. Make sure I remember my semicolons. Source is source, excellent, and then dot cursor is 0. Cool. All right, so that's initializing the lexer. Now we need a peek function, because that is going to be done a lot. That operation is going to be done a lot. So we're gonna say char. Yeah. Okay. Char. Lexer peek, and that's gonna take a view into the lexer. Because we're not really modifying it, but I'm of the opinion that whenever you have an array, right? Because as we've discussed in previous streams, a C string is a char array, a character array, right? It is a pointer to a character. And whenever you have sort of like compound types, i.e. Things that comprise of arrays, things that comprise of structures, you know, you want to kind of get a view of them. It's mainly for no copies. It's mainly so you don't have to take that, right? Because you don't know the length of it. So it could be a huge data structure. It could be a huge data structure. And that kind of levels out the copy so it doesn't have to take that, you know, supposedly huge data structure and copy it into this function. You're just taking the memory. You're just passing the bytes, you know? Yeah. Okay, so then we're going to return Lexer source Lexer cursor. It's that easy. Right, okay, so then Lexer peak, and then Lexer, let's do void. This isn't going to return anything. Lexer advance. I called it advance in my notes. I'm not too sure if I want to call it advance. Lexer skip. Let's use advance for right now, just to keep things simple. Const Lexer. Oh, no. We can't use const. But that will be a pointer. And I said it was going to be a pointer and just forgot to type that anyway. We're going to return. Oh, no, we're not going to return. We're going to do Lexer cursor plus plus. And the reason we're defining these functions is just so that we can gain a bit of what are we even making up at the dog. We're taking. I'm sorry, I just read the chat. We're taking what we've been doing in the past streams. We're lexing for a chatbot. Yeah, we're taking what we did in the last streams and kind of just breaking it down. Right, we're making all these functions, and we're going to be tokenizing if we go into this message right here, which is just an example of an IRC Twitch message, what we get with the chatbot. Yeah, okay. Right, so we have advance and then skip white space. Right, so like for those that are just coming in, right, like I essentially over the past couple of days I sort of broke down what the Lexer is and made a couple of notes what we need, what each operation within the Lexer is, which are right here, and that's what I'm sort of referencing. So let's do token. No, yeah, all right. Void Lexer skip white space const chart, right? Or no. Lexer, because we have to advance, which does not take in good old-fashioned const correctness. Gotta love it. So then just while is space while is space, what is space? Peak. Oh yeah, Lexer peak. Lexer. Then we're gonna advance. Kind of that simple. Why are we getting some red squigglies? While is space Lexer peak. No, that's right. What? Why am I getting expected a statement? Lexer advance. So is space Lexer peak. That's right. Am I wrong somehow? Okay. Oh, okay. Yeah, yes I am. Lexer advance. Lexer. I wasn't minding my, I didn't think of the outer parenthesis. Okay, a Lexer for a chatbot. You trying to make the most optimized chatbot or what? Make sure to use O3. March native, I guess. Yeah, no, we're using both. Don't worry. Yeah, Lexer for a chatbot. I thought, why not, right? I thought it'd be entertaining. Something I could stretch out over a couple of streams. Yeah, I'm gonna be that transparent. Anyway, plus, right, Lexer for a chatbot, like, it makes things very sort of robust, you know? It makes things, and I'm kind of thinking of this explanation as I go along. But yeah, Alexa for a chatbot is very much over engineering shit. I could just split by spaces. But if I'm going to implement, say, like, commands and shit, I'm going to need to know the individual tokens, right? So, like, I could do just your basic, you know, split on, where am I? Yeah, split on spaces, and then kind of just carve it up from there. But then it's going to turn into a mess, you know? And you're just going to have so many different moving parts if you just split it by spaces that it's going to eventually become too big, you know? Whereas if you have Alexa, you just have this way of getting each token and like giving some like meaningful metadata, getting some meaningful metadata along with each of the tokens, and that's why we're using Alexa. Chatbot, where if I type math, it's gonna solve it. That would be cool. You know what? Actually, here I will do this. I'm gonna put that down in our references. We'll just. Oh, that's not the right one. Lexer part. I don't fucking know. 5. I'm just gonna say 5. I don't know. Let's see. So I think what that is going to be. I'm gonna say. I'll make it a checklist. Have it solve math equations. Is that okay? Is that what you wanted? You know, actually, I recognize that that username. You've been a chatter in my chat before, haven't you? Yeah. Rodolio, is that right? Perfect. Awesome. Cool. I'm being genuine right now. That actually was a good idea. Like, you know, I didn't think of that. You have been in my chat before. Well, welcome back, I guess. Okay, awesome. Love to see return chatters, you know. I'm being genuine. Okay, so let's get back to this. I recognize the Russian flag. Yeah. Oh shit, yeah, that's right. Okay, I remember our last conversation. Yep, alright. Been a while. Scan word length. Okay, so I'm gonna need the size of the word. So if we encounter a token, a command, yeah, let's use that concrete example. If we encounter a command, then we're going to have to get the length of that command, right? And I don't just mean command, I mean like tokens, right? So like to get the channel name, or if it's like the Twitch keyword priv message, you know, so we're gonna, that's why we're getting the word length, is because we're gonna have to consume that entire word, and to do that you need to advance the cursor of the lexer by its by the length of the token. So that's what we're gonna do. Lexer get word length. We're probably gonna rename these eventually. I'm not too happy with the names, but for right now this will serve our purpose. So what I have for skip word length is sort of the operations of it. We're gonna take in the lexer. I don't remember if it's gonna be, no, yeah, it's not gonna be const. Yeah, no, because you have to, well, yeah. Okay, so then you're gonna have sort of a length. Do you have a plan for like a token data structure yet, and where are these tokens gonna go? Yes, I do. I have a plan. I have a token array. Right now, so for the end of the stream today, all I just want to do is get individual tokens with metadata, i.e. the token structure here, into a token array and be able to print them. That's all I want to do today. Because we're starting over from the previous streams. So to have a proof of concept like that would greatly increase our chances of success for the next stream. So, yeah. So these tokens are going to go to a list. To answer your question. So size t, let's do I. Yeah, let's do I. It's just going to be a counter. So then we're going to say while, I guess peak, Lexer. Yeah, while, because so the condition I have here is while there is a cursor, or while there is a character at the cursor, while at the cursor something within the source still exists. Right? Or no, I can't use peak because we're using I. And actually, you know what? Let's call this length, now that I think about it. Yeah. Looks tight. Yeah, thank you. So we're going to say, while Lexer source at Lexer cursor plus the length, right? That's the algorithm we're going to use. As well as not is space, while it's not space. The Lexer cursor, or Lexer source at Lexer cursor. So while we have something in the stream, while we have something that isn't a space, and Lexer. Oh, that's something. Ah ha ha ha. All right, I just thought of that. I just thought of this. Sorry. We're gonna say token const pointer token type to string. This function returns. It's a good idea. Oh, I think writing down that you want to do in text before you program, it is very smart. That's something I also should do every time well, yeah, I don't normally do that, but if you see the previous streams, I was fucking struggling with this idea. So that's exactly what I did. Is I don't normally write down what I need and the steps to complete them, but I'm slowly realizing something I should start doing. Yeah. So then we get token kind. Let's do kind. Return cursor, right? Yeah. So the default, we're going to assume default. We're going to assume. Oh, switch on the kind. There we go. I'm like, why am I not getting syntax highlighting? Forgot my switch. So our default case is going to be token end. And in that case, we're just going to return null. And we are going to have to check for that case. But I think it's better than returning like unknown token or whatever, or crashing. I think that's okay, because we can control where the program crashes in that case. We're not just going to crash in the token type to string function. We can do a null check and then decide if we want to crash there. Right, okay. And then case token. Whoops. Token. What other one do we have? Colon. Break. And we're gonna return a colon. I do keep checking chat, just so that I don't miss anything. And lexer oh. Should I do peak? I think I should do peak. I think peak will work. Lexer peak. Lexer and lexer peak is lexer does not equal a lexer, a token type to token type to string is going to be token type to string. Oh, okay, so we're just going to do token colon. There we go. And we would need to dereference it, which is okay. Normally I wouldn't do that, but in this instance, because we know for a fact it is going to be a colon, and it's going to be one single character, we can dereference it to get a character representation. Usually what you want lexer to do is to produce a series of tokens no matter what the input is. Any type of crash logic should only be in the following parser. Exactly. That's kind of what I'm getting at. Let's see. Right, okay. Get word length, then length plus plus, and we're going to return length. Awesome, 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 awesome. All right, then we need to get the next token. Oh, excuse me. Lexa next token. Increase the length. Right. I want to look to that logic and make sure. Yeah. Okay. Okay. Yeah, I don't want to crash. All right. So then lexer next token, we're going to take in the lexer. And let's look at my notes here because this is pretty extenuant. Extenuant? Is that the right word in English? I don't know. It's pretty verbose. Skip white space. Obtain a pointer to the source of the cursor. Any of the following steps because I don't use the aforementioned dereferenced pointer. If there is no character at the current pointer, i.e. peak, return token n type with the length of 0. That is our crash state. Crash state. It's not going to crash, but you know what I mean. Or that is the error state. Yeah, I'm going to use error state as a better turn of phrase. If the character at the current pointer, i.e. peak, is equal to a colon, skip and return the token, advance and return the token colon with a type length of 1. Obtain a pointer to the source of the cursor, the start of the word. So that's going to be the start of our word. Obtain the word length, increase the cursor by the word length, return the token as a token word with the pointer to the start of the word as the data. Okay. Okay. I understood that, I promise. Joke. Okay, so we're going to skip the white space. Skip white space, and this is a void function, so I don't need to check anything. Lexer. I wrote a parser for C once, got into the abstract syntax tree, didn't have the strength to go any further. You have to have monk level Zen to write an assembler. Yeah, luckily, I thank my lucky stars, I don't yet have to write an abstract syntax tree, because we're not really doing any sort of, like, structural parsing, per se. You know, we're kind of just getting these tokens, you know, like, we're not lexing a language. We're not tokenizing a language. You know, we're just analyzing it lexicographically, if that makes any sort of sense. So, like, an abstract syntax tree won't come up, probably, most likely. I don't know. If I'm feeling a bit over-engineerish, I might. But yeah. Oh, you're gonna have to write once to solve my math expressions. Yes. Yes. You'll see. So I have plans to do something like a lookup table for like commands and shit. So all I'll have to do is write like a function, solve equation, whatever. You'll see. That won't be this stream, but it will be in future streams. Yeah. So like you'll just have to put in the command like !math, for example, and it'll just use that lookup table to get the previous. And we're gonna do like we're gonna do like quote escaping and things like that. You'll see. This is gonna get fun. Yeah. I gotta say something to. This just crossed my mind. I gotta say something to bring viewers back. Not to give too much away. Obtain a pointer, right? Okay. So then we're gonna say char character, and this is how I want to return a pointer because we have to check the character, and I'm reading here, any of the following steps cannot use the aforementioned dereferenced pointer. So if we can't use like the pointer into the data, then we're gonna have to save the pointer into the data as as a variable. But you need some sort of tree to solve an expression with brackets and stuff. It's gonna be fun to watch, most likely. Yeah. Oh yeah. Yeah. We'll cross that bridge when we get to it. How about that? All right. We'll cross that bridge when we get to that. Because right now we're just trying to get a stream of tokens. You're thinking you're on the right track. Don't worry, we're gonna get to that. But yeah, yeah, that's pretty far into the future, is what I'm saying. So we're gonna peek or Lexer peek. Lexer. So we're gonna get our token, our character. At the cursor, and then const char word or token. I'm gonna say start because this is the start of the word. Is going to be the address of character. Full honesty, I'm not entirely sure why that works, but it does. Full honesty, I'm not entirely sure why that works. Like I know what's going on. I know what's happening within the compiler. But in terms of like why that doesn't crash, because we're taking the address of a stack variable, is black magic to me. Think big dream even bigger or something. Yeah, exactly. Yeah. So don't worry about it. We'll get to the maths in a minute, or in a future stream. Okay. So then skip the white space, obtain a pointer to the source of the cursor. That's what we've done. And then we can't use the dereferenced pointer anywhere. Okay. So if character, and I think that's what I'm getting at in my notes. If there isn't a character, there we go, then we're going to return, if there is no character, return token end with length 0. Token init, token end, data is IE peak, right? Lexer peak, good. Return token init. The data, I guess, is just going to be start then. Okay, and the length is 0. Great, so we're at token characters. So let's see. Tokenize, set the source of Lexer. Stack, do while is aforementioned next token function condition to the token type not being equal to token. The rest of this control flow is add each token to either a linear list structure or okay. I'm just sort of trying to understand where I did the list, where I added everything in the list. thinking about our control flow and application lifetime. I think you can take the address of any variable in C. Interestingly, it doesn't even have to have an address, but it still pretends. It's an interesting design choice in C, I'll be real. Do you think it makes sense? It makes sense for now, I think. What you're saying makes sense, definitely. But I think as a design choice, it's going to make sense until it doesn't. You know? I think taking the address of a character... like if you followed, it's not on the Twitch channel, but it's up on the VOD channel. If you followed the Keylogger saga that we did, it was one of like the first things I did on this channel. We used that trick. We took the address of a character into a string, which is kind of where I learned it. But yeah, and that so it works like for specific things. Like if you want to turn something that's a character into a string, you just take the pointer of it. And that, as a design choice, is probably justified. You know, any other really sort of like taking a pointer of a variable as a design choice strictly as a design choice is flimsy, I'm gonna say. I know it's a very broad statement, but yeah, okay. I'm gonna say that. Yeah, okay. Like, you know what? I'm gonna have to clarify what I mean. I'm thinking it over. I'm gonna have to clarify what I mean. Like doing this, like just outright being like, Okay, actually, you know what? I can show what I mean. So like here, right? I would rather do the address of entry passed into the function than do like entry t pointer entry ptr or whatever equals the address of entry. Like that's what I mean. Like this right here, you're adding an extra line of code. Just take the address. Unless you absolutely need it. You know? So that's what I mean. And again, that's strictly within the permutation of a design choice. You know? Again, you can do it. It's just you're wasting a line of code, in my opinion. I'm just kind of surveying because I want to write my own compiler in the far future because I think that variable doesn't have an address, e.g. only lives in a register, should not yield an address. Yeah. No, you're correct. As far as I know. Yeah, that would be correct, yeah. So if the character at the current pointer, we're getting back to the code now. At the current pointer, i.e. peak is equal to colon, skip, and return. Okay, right? So then if we're going to check for the start, right? So else if, yeah, maybe I should group these together. The character is equal to token type to string, colon, token, colon, there we go. Then we're going to return token init token colon data of start, and the length is 1, which is exactly what I'm doing here. Skip and return the token. Oh, I also have to skip. Fair enough. Here we go. And we'll Lexer advance. Lexer. Right, so we call Lexer advance, so I can't put const here, as well as skip white space. Alright, so that's fine. Obtain a pointer to the source of the cursor at the start of the word. Okay, so then we're going to say const char pointer is word is equal to the address at the Lexer source of Lexer cursor. It is intentionally spelled as character. Is that not how character's spelled? Is that a question or a statement? Oh, that is a question. Okay. I just saw a question mark. Is that not how cursor is spelled, or character is spelled in English? Versus character. Is character. Oh, okay. Thanks for catching that typo. I genuinely thought I had the correct spelling. My bad. Character. Yeah. Okay. All right. Obtain a pointer to the source of the... Yeah, English is not my first language, so... I will occasionally misspell things, and I'm glad to people like you for, checking that out. Catching me. Obtain a pointer to the source of the cursor as the start of the word, which is exactly what we've done. And then obtain the word length, right? Size T, word length. Lexer, word length. Unsigned, long. Oh, because I didn't assign a variable. Really, damn. I thought it was. You speak completely without an accent. I do have a slight accent. It's a mid-Atlantic accent. I first started learning English when I was like 5 years old. I'm now in my late 20s. So I don't have a very thick accent. I don't speak like this. English is not my first language. Lexer. And then increase the cursor by the word length. So we're going to say Lexer cursor plus equals length. Return the token as a token word, and then we will return token init token word. We forgot token word. There we go. So, oops. Token word. Yeah. And then we'll do case token word. By the way, is this level of... I know I've said this before, but maybe it was when I didn't have enough viewers on, but, like, is this Zoom okay for everybody? Do I need to zoom out, zoom in, whatever? Just let me know. Impressive. My spoken English is completely garbage. My written English is possible, I suppose. Yeah, I'm the flip. I'm the flip. Like, I could pass for a native English speaker speaking, but my writing is awful. In terms of, like, spelling out words and, understanding the written form of English. Like, I understand code because I learned code in English. It's all about socialization. It is. It's all about socialization in the sense of, like, how you learn something. In which language did you learn something? Will you be most comfortable using? In fact, actually, I was trying to come up with a concept, like, 10 years ago, about, like, creating a language agnostic in terms of, like, spoken language, like Russian, English, German, Swahili, making that sort of a language, like, writing in, just for an example, C, right, with C syntax, but if you wanted to, say, use Arabic as your function names, that would be perfectly fine. I was trying to deal with that concept. It never got off the ground for one reason or another, but I was trying to do that concept, and it solved my problem, is what I'm getting at, is it solved my problem of having to know English to code. Zoom is good, thank you. First time chat, welcome to our Lexing Club. I guess. Yeah, that's good. Okay. Are you saying, yeah, it's good for the Zoom? Okay. Support for Unicode characters for the compiler itself. We will eventually get to that. Don't worry. That will be in the future. Right now we're just trying to get a stream of tokens. Yeah. We will get to that eventually. So we're just gonna say word. Should I token word? No, I don't think I should do token word. Word is fine. That gets the point across. Word. Token word. There we go. And that is going to be word, and the size is the length. And that's gonna get us a string view, and then tokenize, the almighty tokenize. This is going to be. Oh, token init, I have to put up here. Because next token uses token init. So I'm gonna have to put that up here. I do like how Go, and I'm gonna read the chat in a minute. I do like how Go, you don't have to define a function. But like it's a multi-pass compiler. It's not just a one-pass compiler like C is. That is so like having a multi-pass compiler is so like relieving. You know, like I don't have to think, oh, is this going to be in terms of like how the code looks. You know, I don't have to think, oh, am I using a function that has already been defined yet, and did I put this in the header file? It's just, you write the function and it just fucking works. I love how Go works in that sense. You know? Yeah. Is that what you were trying to refer to when you said it had you learning English? Yeah, kinda. Oh, you're talking about, like, the Unicode characters. Yeah, I mean, kinda. I mean, again, the project that I was talking about never really got off the ground. But it was sort of like to solve the problem of like having to learn English to code. You know what I mean? Or at least be competent enough within English to read other people's code. You know, so you just sort of write code in write in like C, Scala, Java, yeah, Python. You know what I mean? But then have, like, say, the function names or the variable names or the type names be in a different language and then just translate it over before the compile step. I probably could do that now. In fact, you know what? I might revisit that project at some point. I'm not sure. Don't take that as a promise, but I don't know. I'm actually, in fact, I'm convincing myself to revisit that project. It sure would be interesting. I do have a decent international audience. You know, I read my analytics. Fair. The worst part is I think the GCC compiler isn't even single pass, but they still make you do it. Is it? Hi, so this is the tail end of the stream. I got rudely interrupted, so I had to edit that out. But just so you know, we do have a working Lexer state, and everything will be back up tomorrow. So go watch that video. If it's up. If not, check out the Twitch down below where everything was streamed live. And yeah, enjoy the rest of your day. Stay safe. Peace.